Okay, for today, it's about exponential functions, and the lesson will be shorter than usual, but it's actually really, really easy. If you knew that the parent function for an exponential looked like this, and you knew that this spot that it touched right here was always 1, and I want to ask you to think about that for a second. Think about it. Tell me the reason that the answer has to be 1. Because what is what? Because x is 0. Because x is 0 right here, then at that moment, that's a 0, and then any base would have been like 2 to the 0 or 12 to the 0. Wouldn't matter. It would be 1. All right. Now, what have I told you is your best friend in graphing? XY chart. Once again, you don't even have to know what this thing looks like. I know it looks like this, and I'd like you to know that, but you really don't even have to know, because if you can make an XY chart like this and stick in some numbers for x, you're just going to play connect the dots. It's easy. What if I figure out the dots are here, here, and here? Well, then I connect the dots, and then I've got my graph of my exponential. And do you think that this one might have been shifted to the right and up or something like that? That's why it would be here. If you know what the parent looks like, it's a good idea, but the XY chart can do everything. All right, let's think about what way this one has been moved. The parent one has been moved. Wait a minute, there's something in there by the x. What's your gut say about left or right? Because that's what it is. It's left or right. You remember those rules? What would this one then be? Right, how far? 2. Good. So this parent one, which would have been here, and do you want to know some of the things on that? If you wanted to know some of the things on that, you could have made a little list of like, well, it was 3 to the x, and then it got moved. Okay, and then you'd have to make an XY chart to find out the things, the original parent points for it. But I don't think that's the smartest way. I think the smartest way is strategically pick some numbers for x, and I'm going to ask you to always just do 4 points. Find 4 points. Once you connect the 4 dots, you'll have a nice curve, and you're done. So it's really just make an XY chart. But don't just blindly like, I'm going to pick x is 7. Well, then you're going to end up with 7 minus 2 is 5. How about 3 to the 5th? That sounds like a pain. So don't just pick randomly. Pick strategically. So what's a good x to pick? 2 works. Why is 2 so good? Because it makes it to the power of 0. Now, don't make the mistake of thinking that everything turns into 1. But 3 to the power of 0 turns into 1. And then I subtract the 6. What is 1 minus 6? Negative 5. 2 comma negative 5 has to be on this graph. I know because I put the points in. 2 and negative 5, and it works. Okay, so 2 over 2 down 5. 1, 2, 3, 4, 5. Do I really know where it's going from there? Well, I kind of do, because I kind of know that this thing was like this, and it got shifted 2 to the right and down 6, which is kind of like this. So I kind of know it's going to look like that, but that alone would have gotten it marked wrong in the test because it only has 1 accurate point, even though it's kind of close. All right, so let's get some more accurate points. Like, what's another good thing to put in? 3, I like it. 3 goes in, and I get 3 minus 2 is 1 for a power. 3 to the 1 is 3, and then 3 minus 6 is negative 3. 3 comma negative 3. There's my second point. And again, 2 points can define a straight line, but when you have a curve, you need to have more than that. Mr. RS, don't be distracted and tell me the next thing we could put in. I like it. I'm going to put in a 4. Then I have 4 minus 2 is 2. 3 squared is 9. 9 minus 6, 3. 4 comma 3. Now, last thought. These have an asymptote that I haven't talked much about. There's an asymptote in the parent one that runs along at 0. Do you get there's an asymptote somewhere in here where this thing will have, it's been shifted, but basically the asymptote that used to be running across here is now going to be shifted down. Think about it. How far down was it shifted? Yeah, this thing will tell you right here how far down it's been shifted. So this asymptote must be at negative 6. So that would be another smart thing to include in your graph is the asymptote at negative 6. 1, 2, 3, 4, 5. Yeah, I had it basically. I was about to touch the asymptote line. And you don't want to do that. These things aren't supposed to touch their asymptote line. All right, there we go. That one's done. So what do you need to get credit on these? 4 points and an asymptote. But in a lot of cases, you can't get the 4th point on there. So then 3 points and an asymptote is fine. Okay? In fact, I'm even, since you're my first class that I was actually here for, I'm going to officially change my requirements. 3 points can define a curve. Do you get why? 2 points can give you a straight line, but you can't tell where it curves. 3rd point, I'll tell you where the curve is. So 3 points will define a curve. So you need 3 points and the asymptote. Okay? To find the asymptote, you always just look and see where to get shifted. Down, this part. So this one got shifted down 8. I can tell you right off the bat, 3, 4, 5, 6, 7, 8 has got them in the asymptote line right and across there at -8 because it got shifted down 8. All right, now let's put in some more points, XY chart. And I suppose I better tell you which ones that I want you to do. I want you to do 1, 2, 3, and 4, but after that, just the evens. 1, 2, 3, and 4, but after that, just evens. All right, so let's find some points quick. I bet somebody's probably already done with this thing. What did you stick in as a good point? X is what? -1, I like it, because that makes the power 0. Once the power is 0, that, be careful, not all of this becomes 1, just that becomes 1. And then 2 times 1 is 2 minus 8. 2 minus 8, -6. 1 comma, -1 comma -6. All right, and I think I might have, no, I think I'm right. I was just making sure I didn't mess up my asymptote line here. All right, let's do a couple more points, and if it crosses the asymptote line, oh no, I did something wrong. All right, I'm going to pick another point, I'm going to pick 1, because then 1 plus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 8 is 0. 1 comma 0. That's a spot that's on my graph. And one more, how about x equals 0? Put a 0 in here. Then I get 2 to the 1 is 2. 2 times 2 is 4. 4 minus 8, -4. 0, -4. All right. There's not much curve in that line, but if I know where the asymptote is, this should work fine. There we go. I have 3 points and the asymptote. Now, does this kind of look like what the parent one was supposed to be? Yeah. Does it kind of look like it's moved down? Yeah. Does it kind of look like it's been moved? What's this +1 thing do in here? Do you remember that that's to the left? So it feels a little bit shoved to the left. Okay, so that's good. What's this 2 in front doing? That's a vertical what? Vertical stretch. Basically, that makes this thing steeper than it would have been because it got pulled up. Okay? So vertical, obviously that's a this way kind of a thing. It's a vertical, like you grab it and you stretch it. You pull on it. Like if it's made of rubber, it would just stretch upwards. All right. Problems 1, 2, 3, 4, and then only evens after that. I'm going to scroll down a little bit further just to make sure there isn't any like gotchas coming up in a second. Hope I captured it instead of wiping the ink. I'm going to try that again. There, clear the ink. Okay. All I need is an XY chart for these guys. Ooh, I remember these. This is the one that you have to do. Okay. First off, that doesn't look like the other kind. It's not growth. What is it? It's decay. And all that means is that the base in here was a fraction. Remember how if you multiply by a fraction, things get smaller, smaller, smaller? Okay, so basically, instead of having a base of like 2 to the x, this is like a base of 1/2 to the x. And that'll make this shape. All right, so then here's the toughest part. I'm glad I did scroll down. I forgot about this kind. It tells me something important here. The black graph shown is this function, which is transformed to make the other ones. So the black one's the parent one. There's my parent one. Now, you can tell, let's do one at a time, that the red one is higher than the black one, and there's 2 ways that could have happened. Do you get it could have just been dragged upwards, and that would make it higher, a vertical shift. If that had happened, though, these 3 points would be just exactly straight up or even up and to the right or something of where they are. And is that the case? No. So this wasn't just a move up. So what's the other way you can get a function to go up? Yes. You could do a vertical stretch. A vertical stretch would make the 1 turn into a 3. This 3 turned into a 5. And this, what is that? 0.33 turned into a 2.33. Notice what I'm doing there? I'm comparing the y values. Here was the original's y value of 3. Now it's 5.5. This one's y value of 1 changed into a 3. This one's y value of a third changed into 2.33. Is it as simple as it's moved up 2? Are all the numbers 2 bigger than the previous? Actually, I think it is. Because I was saying 5.5, I was reading it wrong. The y value here is just a 5. Sorry about that. That's a 0.5 in front of it, so that messed me up. All right. Okay, so the y values. 3 changes to a 5. This one, 1 changes, arrow. It won't let me arrow. 1 changes to a 3. And lastly, 0.33 changes to a 2.33. As soon as you see all those y value changes, now it becomes obvious. Yep, all that happened is it moved up. How far? 2. But why are the x numbers so weird? It did just move up 2. I thought for a second it would have to be a stretch, but it's not. It's an up 2. So to get this red one, we need to take the parent one, which was, by the way, 1/3 to the x, and then we need to move it up 2. That's simple. That's like this. But I'm not done yet. Because did anybody notice that these points are all squished together more? They're horizontally what? Shrunk. See, I mean, these used to be this wide. How wide were they? They used to be a width of 2 between those 2 points. Now it's only a width of 1 between those 2 points. Oh, so it's half as wide as it used to be. Do you remember how to do half as wide? Put a what where? A 2. Should it be, this is important now, inside these parentheses or outside those parentheses? Was it horizontally shrunk or vertically shrunk? Was it the width of the points that got smaller? Yeah, it was. It used to be this wide. Now it's only that wide. See what I mean? It's half as wide as it used to be. So, how do I do half as wide? Don't put a 1/2 on the inside. What do you put on the inside? A 2 on the inside. That is a tough one. We will test you on this, but it may not be that tough because that was really hard to see. All right, you do the blue graph here. Do you get, compared to the black graph, the blue graph is definitely to the left and down. And if you want to tell if there's a stretch factor, you got to look at like the y's and see 1 changed to 3. 1 changed, sorry, wait a minute. Sorry. 3 changed to 1. And 1 changed to -1. Just look at your y value changes, and if they're all just like, well, it went down 3, well then cool, it'll be simple. Then look at all your x value changes and go, okay, then -1 changed to this, the 0 changed to that, the 1 changed to that, and hopefully you'll be able to tell. And by the way, it says 3.02 right there. My gut says that's off a little bit. I feel like that should be like -3 on the nose. I don't know. We'll find out when we're done. We'll see when you look at this, your x value there. This x value right here might be off a smidge. All right. Hate to do this to you, but I did, all I'm leaving you with is one like this. I think I need to give you one more like this. So look up at this problem on number 5. I am assigning, I'll give you the easier of the two, but on problem 5, I want you to do the red one. On number 5, just do the red one. On the other one, I did the first part, you do the second part. So, of course, you can always do more if you want. And I'll tell you, these are the ones I mark wrong on the test all the time. So if I were you, I'd double check that you know how to do this. If you don't, try them all. I mean, there's extra problems in there for a reason. All right, number 8. Number 8, don't forget that the general form for this thing is you take the starting value, you put it here. Then if it's growth, then you use a number bigger than 1. Like, that'd be 50% growth, right? And if it's decay, you use, and I recommend a 1 minus. That'd be 50% decay. And then it's going to leave you a fraction as your base. And then x is the time usually. Since this has time in it, number of hours, that's going to be your x, except it tells you to call it t. So it's not like this always has to be an x. If they tell you to make it a t, then you make it a t. So anyway, you're going to write an equation as your start value, your growth or decay part after a 1 here, and then this will always be your time, which sometimes changes letters from an x. All right, you should be able to answer that. And sketch the graph. When it says sketch, you do not have to have 3 accurate points in an asymptote. This is a sketch. The only thing I'd need to have, I'm not saying that's the right answer, but only thing I need to have is a little bit of label of what these things are, except in this case it tells you to use t instead of x. And then some scale, as in like where was the start value? Do you get when you're on a graph, your start value is right here? Because you start at 0 for time 0. Okay, I've shared everything with you that I can possibly get through in our shortened class period. Your assignment was 1 through 4 and then the evens, but I threw in one extra part of number 5. And there you go. You guys know when we're out this hour? 12:01. Okay, so you still got about 6 minutes. All right, that's all I got for you for today.